determine the exact value of the sine of 67.5 degrees, we're going to either have to use a double or a half angle identity. So what we're looking for is this number twice an angle that we already know, or is this angle half of another angle that we already know? So in this case, it turns out to be half. So the angle that we know is 135 degrees, which means that if we half that angle, we get 67.5 degrees. So when I initially set this problem up, I didn't off the top of my head think 135. What I did was I looked at this and I said, if I divide it by 2, will I get a number that I know? Or if I multiply it by 2, will I get a number that I know? And if you multiply it by 2, you get a number that you know, one that works out real nice as an angle on the unit circle. So if you multiply by 2, okay, then that must mean to get to this guy right here, we must be halving that angle that we know. So when we half it, we get this 67.5. So here's what I'm going to write. The sine of 67.5 degrees is equal to the sine of 135 degrees divided by 2. So what I've done is I've replaced 67.5 with 135 over 2 because they're the same thing. Now once we're here, we're going to go to our half angle for sine. So that's going to give us the following. The sine of that half angle is going to be equal to, I'm going to write it down here so that I have more room. So -1 raised to the floor function of the angle theta, so this angle up here, 135, divided by 2 pi, which is 360. So we take the floor of this guy, but we need it. It won't really matter whether we've got it in radians or degrees, but to write it like the formula is already, because the formula is in radians, let me put it in radians for you. So 135 degrees is 3 pi over 4. So just 135 degrees. So what I've really got here is 3 pi over 8. But anyway, so we'll do 3 pi over 4 divided by 2 pi. That's going to be that floor function. Then we're going to multiply that by the square root of 1 minus the cosine of the angle, which is 135, or 3 pi over 4. And we'll divide that by 2. The rest of this is just computation. So there's a couple steps. Your first step is to determine theta. So once you know what theta is, okay, our theta here for us was 135. So it's not this angle right here. It's going to be this value up top here. So that's your theta. Then we plug things in. And we simplify. So this is -1 raised to the, now I'm going to do this as a side note over here. So this will be 3 pi over 4 divided by 2 pi, which is the same thing as 3 pi over 4 multiplied by 1 over 2 pi. Notice that the pi's cancel. And I've got 3 over 8. And I want the floor of that, meaning I want to round down, round left I should say. So this guy is between 0 and 1, so it's going to go to 0. 1 minus the cosine at 3 pi over 4. So 3 pi over 4 is a nice, it's that middle angle, so it's going to be a square root of 2 over 2, but remember cosine over in that quadrant is negative. Here's another way to think about the sign out front. So this is negative 1 to the 0, which is positive 1. This guy right here, he'll either be positive or negative 1, depending on what the coefficient is. Or not the coefficient, but what the power is. So how can you figure out this guy without doing this right here? So this mess right here, you can also figure it out by saying what quadrant is your angle in. So sine of 67.5, 67.5 is quadrant 1, and so their sine is positive. So this guy out front should also be positive. So it's another way of looking at it. So this is going to be 1 plus the square root of 2 over 2 divided by 2. So here's where we have to be careful. Now the one out front can go away because we don't need that anymore. And I'm going to get 2 plus the square root of 2 over 2 divided by 2. What did I do? This 1 became a 2 over 2. Now I've got on the inside, I've got 2 plus root 2 divided by 2. Now normally it'd be multiplied by the reciprocal. So this is going to be 1/2. So that's going to be the square root of 2 plus the square root of 2 over 4. If we distribute that square root into both pieces, we get this. And now we can't cancel this guy with this guy. We're stuck at this point. So let's go ahead and check to make sure this is right. So the sine at 67.5 degrees should be 0.92. So we know that this guy is approximately 0.92. Let's make sure that this is also 0.92. So we've got the following. We've got the square root of 2 on the inside here. We're going to add 2 to that answer. Okay, then we're going to take the square root of that answer. Okay. Let's go back. That didn't work out with the order of operations correctly. Let's try this. So we have the square root of 2 plus the square root of 2 divided by 2. We get 0.923, which is our 0.92. So this value here is the exact value. Okay, so here we've got the exact value of the of the sine at 67.5 degrees.